Hi, so welcome to today's discussion. So basically today our discussion will center on levels of measurement. Levels of measurement. So with levels of measurement, we have to know certain properties that a skill or measurement skill could possess. And a measurement skill could at most could possess four properties. And we'll be delving into these properties. And these properties are property of magnitude, property of equal interval, property of absolute zero, then property of identity. So basically, what is property of magnitude? So we normally say that with a property of magnitude, at some instances, that attribute that we are measuring could be judged to be greater than, less than, or equal to another attribute. A typical example is distance. When we see, let's say the distance from Accra to Kumasi is 250 kilometers. And the distance from Accra again to this time around Cape Coast is 150 kilometers. We could see that we have two different parameters. That's 250 km and 150 kilometers. And obviously, we can see that 250 kilometers is greater than 150 km. And 150 km, we can say that it is less than 250 km. But in situations whereby Accra to Kumasi to Cape Coast is 150 km, and we are able to also decipher and know that okay, Accra to Volta region is also 150 km, then we can say the distance from Accra to Cape Coast is the same as or equal to the distance from Accra to Volta region. So it means when it comes to distance, we could have greater than in there, less than, and equal to in there. The same thing applies to distance. Sorry, the same thing applies to length, weight, and so on. Even depression, anxiety, and what have you. It has property of magnitude. The next thing has to do with property of equal interval. So with property of interval, what we are saying is that the unit of measurement between 2 points on a scale, they are more or less like the same, regardless of where it falls. Regardless of where it falls. So a typical example is length. We can say that, okay, when it comes to length, let's say on a ruler, we have 1 cm, then the next one is 2 cm. Then the next one is 3 cm. We can say the distance from 1 centimeters to 2 centimeters, 1 centimeter to 2 centimeters is what? 1. And the distance from 2 centimeters to 3 centimeters is also 1. So it means when we pick 2 points, regardless of wherever it falls, they all have equal points. They are all the same. So it means that length, height, weight, distance, and so on, they all have equal interval. Then the next thing has to do with absolute zero. We normally say that a property has an absolute zero when in theory, we can say in theory that, okay, that property to a large extent doesn't exist at some instances. A typical example is when we say 0 centimeters. it means that at that point in time, there's no length or 0 kilograms. It means at that point, there's no distance or 0 kilometers. It means that at that point in time, the object is not moving. So it is stationary, 0 kilometers. So it means that that property has absolute 0. All right. Then the next one has to do with identity. Identity basically helps us to classify or identify numbers using variables using numbers. With identity, basically we assign numbers to variables just to help us to identify it. That's it. A typical example is gender. And a gender, we have male, female. Oh yeah, I don't have to even use gender. Sex, male, female. So under male, female, we can assign 1 for male and 2 for female. We assigning 1 and 2 doesn't necessarily mean that, okay, since female, their number is 2, it means females are higher than males. No, it is just for identification. So that anytime we see male, we can say, oh, we are using 1 instead of we imputing male on our PC. Just for identification's sake. The same thing applies to religious background, marital status, all the things that we can categorize, all the variables that we can categorize. We could easily reduce it to identity by just assigning numbers to it for identification's sake. All right. So right now, let's delve into the skills of measurement. And as skills of measurement, we have different types. And the highest of them all is ratio skill. Ratio skill. So when it comes to ratio, we normally say it possesses all the 4 properties we've mentioned. All the 4 properties we've mentioned. So one thing you should know is that if it measures, it has all the 4 properties that we've mentioned, then it implies that with ratio, it means with ratio, it basically has magnitude, equal interval, absolute 0, and identity. Hence, we normally say all the physical science properties. When I say physical science properties, I'm talking about length, width, distance, okay, height. They all fall under ratio skill. Why? Because we can say they do have magnitude, equal interval, absolute 0, and identity. So all the physical science properties, with the exception of temperature, all the physical properties, science skills, they do have ratio skill, with the exception of temperature. Why? Because with temperature, we can say that it doesn't possess absolute 0. Why? Because temperature, when we say temperature, it has to do with either it is warm or cold. But in situations or in instances whereby someone tells you, oh, weather is 0 degrees Celsius, it doesn't necessarily mean that the place has no temperature. 0 degrees Celsius doesn't mean that there's no temperature. What it implies is very cold. So that should tell you that temperature, when it is 0 degrees Celsius, when it is 0 degrees Celsius, it means there is still temperature in there. That's the place is very cold. But you remember we said with absolute 0, for us to say that it is the property is or the skill is 0, then that should tell you that that skill or property or attribute that we are measuring, it doesn't exist. Like 0 cm, we can say that there's no length. But when we say 0°C, we can't say there's no temperature. So hence, there is no absolute zero. So it means that temperature will fall under a scale of measurement known as interval scale. Why? Because interval scale possesses 3 out of the 4 properties. It possesses magnitude, equal interval, and identity, but not absolute zero. And apart from temperature, that falls under interval scale, all the psychological constructs also fall under interval. Because at some point in time, when we say zero anxiety, nobody can say, oh, I have zero anxiety. When it comes to me, I don't have any anxiety in me. Nope. So next semester, you'll be doing something in abnormal psychology, and you would appreciate it much better. Because all of us have minute of these psychological constructs in us. What makes it abnormal is when it deviates from the norm. It means that it is too high in our system, thereby causing a whole lot of issues. So it means anxiety, depression, aggression, emotional adjustment, and so on and so forth. They'll all fall under interval scale. Then the next scale of measurement has to do with ordinal scale. We normally say that ordinal scale possesses 2 out of the 4 properties, meaning that it possesses magnitude and identity. So in most situations, let me tune your mind back in SHS and JHS. You could see that especially back in JHS and even primary school, what your teachers, they normally do is that after your final exams, they collate your scores, they add your scores together. Then afterwards, we'll compare your scores with your other colleagues and find out who became first and who became last. So first, second, third, up to last. So they're ranking it. It means they have reduced your scores, which was in ratio to ordinal. So ordinal has to do with basically ranking, finding the positions. So it means when it comes to interval and ratio, we can further reduce it into ordinal and even nominal, whereby ordinal has to do with we ranking the scores. Then with nominal, it is basically about we finding or categorizing our variables. So for instance, we can say length has property of identity because 1 centimeters, 2 centimeters, 3 centimeters. As a researcher, I can use my discretion and say, whenever I see a length of 1 and 2, I'll classify them as 1 by using number 1 for it. Then any length with an attribute of 3 and above, I will then use 2 to assign for it. So it means I have reduced this property, which is ratio, to nominal by categorizing it, or by categorizing it and assigning numbers to it for classification or identification. All right, so that's all when it comes to skills of measurement. That's all when it comes to skills of measurement. So you need to also know the skills of measurement and the type of test you're supposed to use and some examples of these tests you have to use. So it means that whenever you realize that within a question, whatever variable they are measuring is either ratio or interval, then you have no other option than to use a parametric test. And these are some examples of parametric tests. So it means when it comes to parametric test, the scale of measurement should either be ratio or interval. Ratio or interval. Okay. Now, the next thing has to do with non-parametric test. With a non-parametric test, its scale of measurement should either be ordinal or nominal. So when you realize that ratio has been reduced to ordinal or nominal, then it means this time around you can't use a parametric test because it has been reduced to the lowest, that's ordinal or nominal. Hence, you're supposed to use a non-parametric test. And these are some examples of non-parametric tests. All right. So it means that there are two main assumptions underlining a parametric test. A parametric test. So any of these tests, the assumptions that I'll be stating, the two main assumptions I'll be stating, it runs through all these tests I have just circled. So with a parametric test, the scale of measurement should either be ratio or interval. That's one first assumption you need to know. When it comes to parametric test, the scale of measurement should either be ratio or interval. Also, with parametric tests, we normally transform their scores into something known as a normal curve distribution. A normal curve distribution. We normally transform their scores into a normal curve distribution. So one may ask, what is a normal curve distribution? We normally say that with normal curve, there are certain characteristics you need to know. It is symmetrical. Okay. And yet at the same time, the mean, median, and mode for any normal curve distribution should be zero. Should be equal to zero. Also, we normally say it has a bell shape. And again, we transform their scores, the scores using z-scores. So these are the basic features or characteristics of a normal curve distribution. So me saying z-scores, what comes to mind? Me saying z-scores, what comes to mind? It means that when it comes to these parametric tests, okay, after maybe we've gotten their information. So let's say I have a scores for some group of students that I sampled, 1, 2, and 3 on their maybe anxiety scores. And group and participant number 1, anxiety score was 5. And participant number 2, the anxiety score was maybe 2. Then this person, the anxiety was 4. I need to transform these scores, 5, 2, 4, into a z-score. And for me to do that, normally I'm supposed to calculate the standard deviation and the mean of these scores. So sometimes maybe the standard deviation that I had was maybe 2, and the mean, that's the sample mean, and the sample standard deviation that I generated. I had a mean of maybe 3. I can be tasked to transform these raw scores. These are the raw scores I'm talking about, 5, 2, and 4. I can be tasked to transform these raw scores into a z-score. And the formula for any z-score is z, which is the z-score, is equal to x minus m r over s, where this x represents the raw score value, then m represents the mean value, then the s as the denominator represents the standard deviation. So it means the formula for any z-score is raw score minus mean over standard deviation. So let's try and calculate this. Let's say my z-score was what? Was 5. Sorry, my raw score was 5. So with a raw score of 5, I need to find its z-score. So it means that it will be 5 minus, and I had a mean of 3, so 5 minus 3 r over, and I had a standard deviation of 3, which will be 3. So 5 minus 3 will be what? 2 over 3. And 2 over 3 will give me, 2 divided by 3 will give me 0.66666. So it means when I transform a z-score of 5 on a normal curve distribution by, when I find a raw score of 5 by finding its z-score, I'm supposed to get a value of 0.667. That's the value I'm supposed to get. And you can do same for this a raw score of 2 and 4. So let's try and do the raw score of 2 and 4 and see if we will get certain things. So like the same thing, using the same formula. Z is equal to the raw score, which is x, minus the mean over standard deviation. And bearing in mind that we had a standard deviation of 2, mean of 3, using the same thing. So this time around, our raw score is 2. So it will be 2 minus the mean, which is 3, r over standard deviation of 3. And this will give us -1 over 3. And that will be our z-score value when our raw score is 2. So it will be -1 over 3. And that will be -0.333. So that's how you do your calculation. And that will be all when it comes to today's discussion. So thank you very much. And it was a pleasure having this discussion. See you next time.